Hello folks, this is a quick video for you on degrees and radians. So this is not a topic that I typically test you all on, but it is something that you're going to need in your Algebra 2 class, right? Whatever math class you're going to next. You typically need to know about the difference between degrees and radians and how to convert between the two, okay? So just like any distance that you could walk or run or drive, degrees or angles can be measured using more than one unit, right? So like a distance can be measured in feet, centimeters, yards, miles, meters. There's so many different units that you can use, right? And there's ways and like rates or formulas that we use to be able to convert from one unit to another for distance, right? For example, if I gave you a distance measurement in feet, then you would multiply that number by 12 to get that same distance measurement in inches. Okay, so angles have the exact same thing. So angles can be measured using more than one unit. The unit that you all are the most used to, and frankly, the most common unit for you up to this point is degrees, right? We've really only measured angles in degrees, anywhere from 0 to 360, okay? But there is another unit that we can use to measure angles, and that unit is called radians. Okay, so what I'm going to do for you in this video is basically provide you with the conversion rate. So how to go from degrees to radians and how to go from radians to degrees back the other way. And I'll do a couple of examples for you. Okay, so the rule, if you start with degrees and you want to go or convert your degree measurement into a radian measurement, you multiply the degrees by pi divided by 180. Okay, so that is going to give you your radians, your radian measurement. Okay, now when you convert degrees to radians, okay, radians always are written as some number with a pi next to it. So even though you have this pi symbol right here, you're not actually going to multiply it through. Like you won't use the pi symbol on your calculator to figure out what this like long decimal is, right? Your answer for in radian form will be some number or fraction with a pi stuck on the end, right? It's basically like you're keeping your answer in terms of pi, okay? So here's an example for you. I want to convert 120 degrees to radians. Okay, so my degrees is 120, and I'm going to do times pi over 180. Now, the best thing to do, right, is ignore the pi and just take this, whatever this is, okay, and figure out what this fraction or decimal is. So figure out this fraction or decimal. Okay, and just ignore the pi because you're going to stick the pi on the end regardless, right? So here, 120 divided by 180, this is essentially what you're doing. 120 divided by 180 with a pi stuck on the end. Okay, so that you can either reduce the fraction. If you reduce that fraction, that reduced fraction is 2/3. So 2/3 pi, or you can plug 120 divided by 180 into your calculator, which is 0.67 if you round, and then you stick a pi on the end. Okay? Once you get to that point, you are done with the problem. Okay? You don't have to do anything else. Now, I will tell you, once you get to Algebra 2 and further math classes, the radian in fraction form is more proper than writing a radian in decimal form, but you can use either, but this is the more proper form, okay? All right, so going the other direction, it's really very similar. The only difference is we're going to flip this fraction. So if I start with radians and I want to go to degrees, the rule is you multiply by 180 divided by pi, rather than pi in the numerator and 180 in the denominator. So literally all you're doing is flipping the fraction. And I'm hoping that in your intuitive math brain, like that kind of makes sense, right? Like when you go from degrees, or not degrees, when you go from feet to inches, you multiply by 12. When you go from inches to feet, you divide by 12, which is the same as multiplying by 1/12, i.e. just flip the fraction, right? It's your reciprocal fraction, okay? All right, so here, we're gonna do an example, okay? So I would like to convert pi over 5 to degrees. Okay, so pi over 5 is my radian, so I have pi over 5 times 180 divided by pi. Now, because you have a pi in the numerator and a pi in the denominator, which will always happen because radians are written in terms of pi. They always have a pi in them. The pi will cancel each other out every single time. So all you really have to do is divide these. Okay, so all I really have here is 180 divided by 5, which is 36 degrees. Okay, pretty simple. It's just it's just some straight multiplication and division here. Okay, so what I want you all to do is scroll down if you're following along with me here. If you look at this, I have an example here, okay, and then there's one problem here that's asking you to convert these two degree measurements to radians and these two radian measurements to degrees. So what I want you to do is pause the video, try this out, okay, and then check back with me in a minute to see how you did. All right, folks, so go ahead and check your answers against mine. So part A, you should have gotten 1/4 pi or 0.25 pi, okay, because 45 divided by 180 is 1/4 or 0.25. Okay, for part B, I did not realize that I did the same example previously in the video as I had here. So you should have had that one already. It's 2/3 pi or 0.67 pi. For part C, you should have gotten 22.5 degrees, right? Because 180 divided by 8 is 22.5. Okay, and then part D was slightly tricky, right? It just had one little extra step, right? Because you had 9 pi over 4. So the pi's still cancel each other out, but you have a 9 in the numerator rather than a 1, right? So you have to do 9 times 180 divided by 4, which is 405 degrees, which I know is more than the number of degrees in a circle. Okay, that's okay. And you'll see why when you get into algebra 2 and pre-calculus. But if you're curious as to why it's okay that we have a degree value larger than 360, feel free to reach out to me. I'm happy to kind of tell you about that as a little bit of an extension of this idea. All right. So that is it for this video, you all. I'll see you in the next one. Bye.